All right, so the problem at hand, how much weight do you lift when you do a push-up? So the way we modeled this question was we drew it as a triangle. The length from here to here, which is the same as the length from here to here, that's the length from the human's feet to their arms. And the way we got this is we labeled the center of gravity, and we basically, give or take, we made it half the length from the feet to the arms. And then this angle right here, this theta, would be the angle of in which how high the human would be after doing a push-up. And the way we got this right here is we derived it from the total length of the human being. So this is the vertical distance, so we used trig, and we ended up getting the length of the entire human sine theta.
Okay, so in order to figure out how much weight a person lifts when they do a push-up, we know we have to find the total work of the arms. So we labeled the work substrate A as the work done by the arms. And we know that work is force times distance, where force is the person's weight, which is mass times gravity, and distance would be this we got here, which is L sine theta. So we also need to know the work done by the center of gravity, which we also know is force times distance. But here, force is the same, mass times gravity, but the distance is going to be 1/2 L sine theta, like we already determined here. And lastly, we know that the work of the arms and the work of the center of gravity have to be the same. So we wrote them out in variable form and then solved by dividing by L sine theta, which eventually got us to the force of the work of the arms equals 1/2 mass times gravity.
Okay, so for example, we use a 70 kilogram person that's 170 centimeters long, and we use the WA, the work of the arms, and the work of the center of mass, and we equal them to each other. So we use the work of the arms equals F times 1.7, which is the length, times sine of 20, which is the distance. And then for work of the center of mass, we got 70 times 9.8 times 1.7 over 2, which is half the length, times sine of 20, and we equaled them to each other, and we ended up with 1/2 times 70 times 9.8, and we got the force is 343 newtons, and that's the work done by the person.